Alright, stop whatever you're doing for a second and let me blow your fuzzy little brain. Did you know there are creatures on Earth that can survive in 200 degrees Celsius? Yeah, 200! That's hotter than your oven on pizza night, hotter than a car dashboard in Arizona summer, hotter than my poor laptop when I dare to open 3 Chrome tabs and Spotify at the same time. Now, for us normal living beings, like humans, rabbits, goldfish, and succulents from IKEA, 200 degrees means instant soup. You don't even get to scream, you just get promoted to biological ramen. Meanwhile, there are microscopic weirdos out there who look at boiling water and say, spa day. They hang out in lava, chill in hot springs, and party around deep-sea volcanic vents like it's their private jacuzzi. And here's where my brain breaks. How is that even possible? I mean, I can't even survive a hot shower that's slightly above cozy carrot tea without panicking and hopping out like a dramatic soap opera star. Yet bacteria are flexing in conditions that make volcanoes blush. I'm just a dumb rabbit, but I need to know. Who handed these microbes the cheat codes to life on nightmare difficulty? Are they mutant superheroes, alien scouts training for interplanetary travel, or just nature trolling us with the ultimate survival hacks? Buckle up, because today we're diving headfirst into the fiery world of hyper-extreme life forms, the organisms that laugh in the face of boiling death. And trust me, by the end of this, you're gonna rethink what too hot to handle really means. Okay, so before we roast ourselves alive trying to understand these lava-loving weirdos, we need to drop one word into our vocabulary: extremophiles. Sounds fancy, right? But really, it just means extreme lovers. These are organisms that don't just tolerate conditions that would obliterate us, they thrive in them. You've got critters that love acid so strong it could melt your phone case, bacteria that live in saltier than a TikTok comment section water, and microbes chilling at pressures that would turn a human into spaghetti sauce. And then there are the heat junkies. Thermophiles, literally heat lovers. Most of us die at 40 degrees C fevers, but these guys start the party at 60 degrees. And then you've got their big brothers, hyperthermophiles. These little monsters don't even roll out of bed unless it's hotter than boiling water. Forget hot tubs, they're out here treating molten vents like a 5-star resort. It's wild to think about, because our entire idea of life is based on what works for us. We need cozy temperatures, a breathable atmosphere, and snacks that don't run away too fast. But extremophiles, they flip the script. They live in places that look like instant death cheat codes in a video game. Places where you'd expect to find Darth Vader building his volcano fortress, not microbes casually sipping magma tea. And here's the kicker: extremophiles aren't just surviving. They're not clinging on by a thread. They're actually thriving, dividing, evolving, making little bacterial families in conditions that make my fur curl just thinking about them. So the real question isn't just how do they survive, it's why stop at Earth? If life can thrive in literal lava soup, who's to say it's not hiding under the icy crust of Europa or chilling near methane geysers on Titan? But let's not jump galaxies just yet. First, let's meet some of the hottest celebrities in the microbe world, the ones that can handle heat levels that would turn your ramen into ash in seconds. Alright, let's get specific. You've met the family, extremophiles, but now it's time to zoom in on the hottest VIP members, the thermophiles and hyperthermophiles. Thermophiles are like the warm-up act. They love heat, but they're still kinda reasonable. Think 60 degrees C to 80 degrees C. That's hotter than your hottest sauna, but still in the realm of maybe a daredevil human could try it for 2 seconds before becoming steamed dumplings. But hyperthermophiles? Oh boy, these guys start the game at boiling point, 100 degrees C, and just keep going. For them, 113 degrees C is basically room temperature. One star of the show is Pyrolobus fumari, a microbe found in black smokers, those underwater hydrothermal vents belching out superheated water from Earth's crust. This little badass holds the Guinness record for living comfortably at 113 degrees. That's not just surviving, that's Sunday brunch. And then there's Methanopyrus candler, another deep-sea veteran that casually reproduces at 122 degrees. Imagine dating someone who insists on candlelight dinners, except the candles are literal lava torches. But wait, didn't I promise you 200 degrees? Here's the twist. In lab experiments, scientists discovered that some bacterial spores, basically survival capsules for microbes, can endure insane spikes of up to 200 degrees. They don't exactly throw pool parties there, but they tough it out like champs, waiting for conditions to cool down so they can wake up and start multiplying again. It's like hitting pause on life, camping in a volcano, and then casually pressing play once things calm down. This is where my dumb rabbit brain short circuits. Like, my microwave taps out at 120 degrees. My carrot cake recipe dies at 180 degrees. And these spores, they just shrug at 200 degrees like it's a minor inconvenience. Who are they? Terminator bacteria? And here's the kicker. These aren't fringe accidents. Hyperthermophiles represent a whole ecosystem at the bottom of the ocean. While we're up here worrying about air conditioning bills, they're thriving in what looks like Satan's aquarium. Entire microbial communities, all powered by the heat and chemicals blasting out of Earth's crust. So yeah, thermophiles and hyperthermophiles are basically life's overachievers. While the rest of us collapse in the summer sun, they're like, bro, wake me up when the pool hits 150 C. But how exactly are they pulling this off? Because let's be real, if I sat in boiling water, I'd be rabbit stew in under 5 seconds. What's their secret? Turns out it's not just luck, it's hardcore biology engineering on a molecular level. Now, let's talk real estate. If you're a thermophile or hyperthermophile, where exactly do you buy property? Spoiler, not Miami Beach. The hottest hangouts for these microbes are hydrothermal vents, those giant cracks on the seafloor where superheated water blasts out at temperatures well over 300 degrees Celsius. Picture geysers, but underwater, surrounded by total darkness, crushing pressure, and chemicals so toxic they'd strip paint off a car. For you and me, that's instant death soup. For hyperthermophiles, that's basically Las Vegas on a Saturday night. Then there are hot springs, like the famous ones in Yellowstone National Park. You've seen those colorful pools that look like someone spilled a giant bag of Skittles into the earth? Those crazy colors aren't just pretty, they're entire microbial cities. Different microbes dominate at different heat levels, painting rings of green, orange, and yellow like a psychedelic lava rainbow. Meanwhile, tourists are standing there taking selfies, not realizing they're basically photographing alien civilizations. And let's not forget lava caves. Yeah, actual lava tubes where the rock is still sizzling. Some extremophiles cling to mineral deposits in these places, surviving on the tiniest chemical snacks leaking from the earth. It's like living in an oven and snacking on crumbs that fall between the racks. What blows my fluffy mind the most is the pressure. At hydrothermal vents, the weight of the ocean above creates pressures hundreds of times greater than at sea level. For a human, it's like being hugged by an angry mountain until your bones crack. But for microbes, it's the perfect cozy blanket. Combine that with heat and toxic chemicals, and you've got what scientists call a hostile environment. Except clearly it's not hostile if you're the right kind of creature. It's paradise. And here's the metaphor I can't get out of my head. Imagine cooking instant ramen at the bottom of the ocean. The water is boiling, the pot is crushing down on itself, there's no light, and the seasoning packet is literal sulfur. You and I, dead in seconds. The microbes, bon appetit. So yeah, these habitats might look like hell to us, but to thermophiles and hyperthermophiles, they're just home sweet home. Which makes me wonder, if life can be this chill about living in an environment that doubles as a natural crematorium, then maybe habitability isn't as limited as we once thought. But how? How does life avoid getting cooked into soup? The secret isn't just in the location, it's in the biology. And trust me, once you see what their cells are packing, you're gonna realize microbes are running molecular level cheat codes. All right, let's get to the million-carat question. How the heck do these microbes not get boiled alive? I mean, if I jump into boiling water, congratulations, you've just made rabbit stew. Yet these guys keep multiplying like it's spring break in magma. The secret? Hardcore biological engineering. First up, proteins. Proteins are the molecular machines that keep cells alive. For normal life forms, heat scrambles them like eggs in a frying pan. That's why you can't uncook an egg. Its proteins are denatured, twisted into useless spaghetti. But thermophiles, their proteins are heat-proof. They're built with extra stabilizing bonds, kind of like scaffolding that keeps them from wobbling apart. Imagine Lego bricks glued together with superglue. You can heat them up, shake them, even drop them, and they'll still hold shape. Next, cell membranes. Ordinary cell membranes would melt or leak like butter left out on a summer day. Hyperthermophiles, however, use special lipids that are ridiculously sturdy. Instead of falling apart, their membranes actually get more stable in high heat. It's like having a house that turns into reinforced concrete the hotter it gets. Meanwhile, my fur just frizzes up at the faintest hint of humidity. And then there are enzymes. These are the specialized proteins that do chemical work, breaking stuff down, building molecules, basically the cell's workforce. In humans, enzymes stop functioning when it gets too hot. But in hyperthermophiles, their enzymes love the heat. Some even refuse to work unless it's boiling. One famous example is Taq polymerase, an enzyme from Thermus aquaticus. Without it, modern genetics wouldn't be possible, because Taq is the superstar behind the PCR technique, aka the process that lets scientists copy DNA billions of times. So yeah, without heat-loving bacteria, we'd be stuck in the dark ages of biology. Think about that. The same bugs living in scalding geysers are helping us diagnose diseases, solve crimes, and explore the human genome. It's like discovering that the best IT support for your computer lives inside a volcano. Now here's where it gets funnier. These microbes also produce special heat shock proteins, which are basically microscopic bodyguards. If other proteins start to wobble in the heat, these chaperones rush in, straighten them out, and tell them, "Hold it together, bro." Meanwhile, I can't even keep my posture straight in a yoga class. And let's not forget their DNA stability tricks. Normal DNA would unravel in extreme heat like a cheap zipper, but extremophiles pack extra stabilizers, proteins and solutes that lock the helix in place. Think of it like wrapping your fragile crystal wine glass in bubble wrap, duct tape, and then locking it inside a safe. The big picture? These microbes aren't just lucky, they're optimized for survival. Every part of their molecular machinery is tuned to handle conditions that would roast us alive. It's not survival by accident, it's survival by design, courtesy of billions of years of evolution. And honestly, I'm jealous. I burned my paw on a toaster once and I'm limping for hours. These guys, they're practically bathing in toaster coils. So now we know their tricks: heat-proof proteins, ironclad membranes, lava-proof enzymes, and DNA bubble wrap. But the story doesn't end there, because the real question isn't just how they survive, it's what this means for us. And spoiler alert, it could change how we think about life on Earth and way beyond. So what's the big deal? Okay, sure, microbes can chill in lava spas. Cool party trick. But here's where it gets wild. These little critters might literally reshape how we think about life itself. First up, astrobiology. If life can survive in boiling oceans here on Earth, then maybe icy moons like Europa or Enceladus are not so dead after all. Underneath their frozen crusts are oceans warmed by hydrothermal vents, just like the ones our hyperthermophile buddies love. Translation? If microbes can handle 200 degrees Celsius down here, maybe somewhere out there, alien microbes are soaking in cosmic hot tubs too. Forget little green men, maybe it's little lava bugs. Second, biotechnology. Remember Taq polymerase, that heat-proof enzyme from Yellowstone bacteria? It's the backbone of PCR, which is used in everything from medical testing to forensic science. Yeah, when you swab your cheek and scientists pull out your DNA, you can thank some hot spring-loving microbe. Without it, modern genetics would be like trying to copy a novel by hand, letter by letter, instead of using a photocopier. And it doesn't stop there. Extremophile enzymes are being used in laundry detergents, biofuels, and even industrial chemistry. Why? Because they don't care if things get too hot, too salty, or too acidic. They just keep working like the ultimate overachiever employees. Zero complaints, no coffee breaks. Meanwhile, I stop functioning if I don't get at least 3 carrot lattes a day. Finally, there's the big philosophical twist. If life isn't limited to cozy Earth conditions, then our definition of habitability is way too narrow. Life might be way more common in the universe than we ever dare to dream. The universe isn't asking, can life exist here? It's whispering, why wouldn't it? So yeah, the takeaway is huge. These tiny heat-loving bacteria aren't just surviving in extreme conditions, they're expanding the very borders of what life means. And honestly, that's both inspiring and a little terrifying. If microbes can turn lava vents into family homes, then what other impossible places might be hiding life right under our noses? All right, time for the spicy twist. When I said microbes can handle 200 degrees Celsius, I didn't mean they're just chilling there like it's a day at the beach. Most of the time, it's not their active, everyday lifestyle, it's their survival mode. See, many of these heat-proof legends pull off the stunt by forming spores, tiny armored capsules that let them hibernate through the chaos. In this form, they don't eat, they don't move, they don't Netflix and chill. They just wait. Scientists have blasted spores with extreme heat, radiation, even space vacuum, and they still bounce back when conditions calm down. Basically, microbial dark magic. So when you hear life at 200 degrees Celsius, it's less like microbes throwing a rave in a volcano and more like them hiding in a bunker until the firestorm passes. Still impressive, but it's important to know they're not sipping lava martinis in there. And honestly, that's what makes them even scarier. They don't just thrive in extremes, they endure them, patiently waiting to reboot when the rest of us would be toast. If that's not the ultimate survival cheat code, I don't know what is. Which brings us to the final question. What does all this tell us about life, the universe, and everything, including dumb rabbits like me? So, here's the big picture. Life isn't fragile, it's ridiculously tough. From boiling hot vents to scalding springs, microbes have turned Earth's most brutal environments into playgrounds. They bend the rules of biology, laugh at our definition of too extreme, and remind us that maybe, just maybe, the universe is crawling with life in places we'd never expect. And me, I'm just a dumb rabbit, sweating through a lukewarm shower while these bugs flex in literal lava. It's humbling, terrifying, and kind of hilarious all at once. But hey, that's the magic of science. Every time we think we know the limits, nature dunks on us with something stranger, tougher, and way cooler. So, if you enjoyed this fiery little adventure, smash that like button, subscribe, and hop along with me for more weird, wonderful science stories. Otherwise, the only thing hotter than these microbes will be my broken rabbit heart.